Okay, so hey, we are back. This lecture, we're going to look at acid-base balance, pH, what that is, what alkalosis and acidosis are, and the types of those. Then we'll get into, okay, so how does the body balance these two during exercise? And this is kind of the next step after we've looked at lactate, because we mentioned lactate is an acid. And so that's bad. And one of the things we said before is the body does everything it can to keep pH normal. It's a big deal. And so we're going to devote a whole chapter, this is chapter 11, to how does the body do this? How do we balance this idea of acids and bases? So let's just go through some basic terms here. If we're going to talk about an acid, again, you probably had this in Bio 1. If you had me in human structure and function, we talk about this as well. An acid is any molecule that liberates or gets rid of hydrogen ions. All right. And so lactic acid being one, though it's certainly not the only one in the body. There are many, many other ones. It is the big one we'll talk about. A base is then the opposite of that, a molecule that will combine or accept hydrogen ions. The most popular one we're going to talk about is bicarbonate. That's a big one, and then blood that we'll look at. And this gets us to this term of pH. And really what pH is a number that gives us an idea of how acidic or how basic something is. Now, pH is a little weird in some respects because it's the pH is the negative log of hydrogen ions. If you remember from like high school calculus, we talked about logs. I'm not going to make you calculate that. What we do need to know is that the scale goes from 0 to 14, and 0 being acidic, 14 being basic. When we talk about things that we're familiar with, water, at least distilled water, is a 7. It's kind of the middle pH. Your blood is somewhere between 7.35 and 7.45. And you can see some other things on here, milk, things like that, vinegar, lemon juice, not surprisingly acidic. Things like baking soda, pneumonia, some cleaners down here, or bases. So I want you to have some idea what this scale is, and that if we have lower numbers below 7, that's acids, those are acidic, and numbers above 7, from 7 to 14, those are bases, those are basic. Now, from this, we have acidosis, acidic, and alkalosis, which is base. And again, we've said before that we try to keep pH as normal as we possibly can. Doesn't mean the body's perfect at it. And so there are times we are in acidosis, and there are times we're in alkalosis. And there's really only two ways for our body to really deal with hydrogen ions. Maybe a better way to say it is to get rid of them. And so what we could say is the two ways to do that. One is through respiratory means, and we'll talk about how we do that in a second. And one is through more metabolic, really the kidneys. And so a good way to think about it when it comes to hydrogen ions, there's only two ways stuff's going out. We can get rid of them breathing through CO2, or we can get rid of them through the kidneys. Now, because of that, not only is there acidosis and alkalosis, there are different conditions that may cause it. So, you may have, for example, respiratory acidosis, which is when pH is low, but it's related to respiratory issues. You may have metabolic acidosis, where again, pH is low, but it's not because of respiratory issues and inability to get rid of CO2. It's because there's something else metabolic, maybe related to the kidneys, that's causing that. We're going to get into each of these a little bit more in depth. I just want to kind of set the framework here. We also have metabolic alkalosis and metabolic, actually that should say respiratory there, my apologies. Respiratory alkalosis, so that, just imagine respiratory. In fact, we'll just type that in there. I'll type that in later. So that's respiratory, and here we have metabolic. All right, so respiratory alkalosis, metabolic alkalosis. And again, pH greater than 7.45 because of respiratory means, metabolic because of more renal issues. So what does this look like? Well, some of these you're familiar with. In fact, my guess is you have dealt with these situations before. I don't know a better way to say that. When we talk about metabolic acidosis, a lot of things can cause this. One of the more common ones, at least one of the ones that we may be familiar with, is diabetes. So in diabetes, when you have an inability to control insulin, one of the byproducts of that process is producing ketone bodies. We call it ketoacidosis. Right? And that is one means to which pH would drop. And that's more of a metabolic acidosis. It's not the lungs issue, it's more metabolic. Obviously, if you're producing a lot of lactate, that would also fall under that category. There's some other ones here you can look at, but these aren't as common. Renal failure, hyperchloremic acidosis, really not very common. Now, metabolic alkalosis, my guess is we've all experienced this at some point. This first one here, vomiting, happens when we get sick and other times. And so when we do that, we lose a lot of digestive acids. Remember, in the stomach, pH is really low. There's acids there. Well, when there's vomiting, we get rid of those. Not surprisingly, pH then increases. The number of acids have dropped. Now, it's fairly common. It happens all the time. You're not going to die from that. If this were to occur chronically over long periods of time, that would be an issue. We also see it with diuretics. That's also a concern as well. So these are more metabolic means. Now let's look at respiratory means. Now here, respiratory, really the two things that are going to cause issues are hypoventilation and hyperventilation. So I want to step back and say, okay, well, how does breathing relate to hydrogen ions? And what's the deal there? How are these two related? Well, if we bring this down a little bit, let me kind of go down in your slides, and I know you're probably following along. One of the things we know is that when we have hydrogen ions, one way to deal with these, one of the ways to buffer these, we'll talk about a little bit later, is we can, through a reaction with carbonic anhydrase, produce CO2 and also water. So if we have a lot of hydrogen ions, we can buffer those, and the byproduct of that is CO2, which we breathe out. We breathe that out. Now, so not surprisingly, if there are things that cause us to decrease ventilation, hypoventilation, and there's things that cause us to increase ventilation, well, that would affect CO2, getting rid of CO2. So sure, not surprisingly, one potential issue that may cause acidosis is respiratory hypoventilation. In other words, we can't breathe out enough, we can't get rid of CO2, and that would cause acidosis. Now, for you and I, probably not a big deal. Both individuals have COPD, which is chronic obstructive pulmonary disease. If there's a neuromuscular disorder in breathing, what's more acute, these could cause hypoventilation, and in theory, respiratory acidosis. Again, not terribly common, but there are millions of people who have this, that this is a big issue. On the other side is respiratory alkalosis. Well, this is the opposite, when we're hyperventilating. One of the places we see this is altitude. We'll get to that later on in the semester, but one of the responses we see in altitude is an increase in breathing rate, irregardless of activity. Stress, we've all experienced stress before. We breathe a lot, we hyperventilate. All right, well, we're getting rid of CO2. Well, if you get rid of a lot of CO2, you're buffering a lot of hydrogen ions, you're decreasing hydrogen ion concentration, and what do? You produce an alkalosis. And so you can see there's this balance between acids and base, acidosis, alkalosis continually. And at any given time, we fall somewhere in the acidic, basic area when it comes to blood pH. In the next part of this lecture, we're going to look at exercise. And so what happens during exercise, how is exercise unique, and how do we then buffer acids and bases during exercise?